Okay, everybody, welcome back to equations. Today in class we talked about how to solve one and two-step equations. So we had discussed inverse operations, how you unstick numbers from variables or how you move numbers to the other side of the equation in order to isolate the variables. And we talked about how with two-step equations, your first step is always going to be adding or subtracting to move the constant over to the other side, and then your second step will always be multiplying or dividing to get the variable by itself. So once you get beyond one and two-step equations, now you're talking about multi-step equations as well as equations with variables on both sides of the equal sign. And with multi-step equations, really, we can think about it in the simplest of terms. There's going to be something that you have to do to prepare the equation for the two steps of adding or subtracting and then multiplying and dividing. So that third step, or that multi-step in the title, is really just modifying the equation as it's presented to you in order to get it ready for solving. So there's really two basic things. There might be three if there's some exponents thrown in there, but two basic things that you need to remember to do. If there's more than one term with the same variable or like terms, so if there's more than one like term, on one side of the equal sign, you can combine. You should combine. I'm going to write CLT. We know that stands for combined like terms. So you should always be combining those. And if there are parentheses, we've got to drop them. How do we drop parentheses? We distribute. And then last but not least, always check your answer, you guys. You may be doing the math correctly and you may get an answer, but that doesn't necessarily mean it's a solution. It doesn't mean that that value for the variable makes the equation true. It might be an extraneous solution, which means that it does not make the equation true. So we want to make sure that you're taking that extra second to check your work and make sure that, make sure you've done it correctly. Make sure that you don't have any computation errors, but also make sure that the solution is, in fact, a solution. So let's look at a couple examples. This first one here, 2 times a plus 3 equals 12. So we've got parentheses, which means we need to distribute. We need to distribute the 2 onto both terms inside the parentheses. And that's going to give me 2a plus 3 equals 12. Now I have modified the equation as it was presented to me to plus 6, because 2 times 3 is 6, equals 12. Now I'm ready for my two steps. Adding or subtracting first. I have a positive 6, so I'm going to subtract 6 to get rid of it. Those cancel out. I've got 2a equals 12 minus 6 is 6. Now I've got multiplication that's sticking the 2 and the a together. I need to do the opposite operation. And the opposite of multiplication is division. So I'm going to divide both sides by 2. And that gives me a equals 3. Now I need to make sure that this works. So I'm going to plug it back in. I'm not going to plug it back in up here because then I'll just have to redistribute. So I'm going to plug it into the modified version of the equation. And that'll give me 2 times 3 plus 6 equals 12. 2 times 3 is 6. Plus 6 equals 12. 12 equals 12. We know it works. Yay! All right. Let's check out number 2. 5a plus 3 minus 2a equals 4. All right. What can I do to modify this to make it ready for a two-step equation? I see a 5a and I see a negative 2a, which means I have like terms that I can combine. 5 minus 2, or 5 plus negative 2, whatever you're more comfortable saying. That's going to give me 3a plus 3 equals 4. Time for my two steps. I feel like I could write a parody song about this, but I won't subject you guys to the torture of me singing. I'm going to move this 3, get rid of that 3 by doing the opposite operation. Since it's a plus 3, I'm going to minus. That will cancel out. 4 minus 3 is 1. So I have 3a equals 1. And now I need to unstick the 3 and the a by doing division. All right, and that's going to give me a equals 1/3. Oh, yay, a fraction! Woo! Just kidding. I know you guys hate fractions. Okay, so now we're going to check 1/3. So I need to fill 1/3 back in for a. All right, I don't need to do it up here. I can do it into the modified equation because 3a plus 3 equals 4 still has the same value as 5a plus 3 minus 2a. We still have the sum total same amount of a's. So I'll do 3 times 1/3 plus 3 equals 4. So 3 times 1/3 is the same thing as saying 3 over 1 times 1/3. And that equals 3/3. So 3/3 plus 3 equals 4. We know that 3 divided by 3 is 1, right? So we can do kind of a shortcut here and just say 1 plus 3 equals 4, and we know that that's true. 4 does in fact equal 4, so a equals 1/3 is our solution. Okay? All right, let's try number 3, more fractions. Boy, you guys are thrilled with this, I'm sure. 3/2 times 2m minus 12 equals 18. All right, so we're going to distribute this 3/2 to the 2m and to the 12. So I'm going to have, I want to make sure I'm not running off this page. Okay. Also, it's been so cold, I apologize for how drawn my hands look. 3/2 times 2m, or 2 over 1m is how I'm going to write it because it's going to make it easier, minus 3/2 times 12, or 12 over 1, equals 18. Okay, so this is going to give me 3 times 2 is 6, 2 times 1 is 1, 6/2 m, minus 3 times 12 is 36, 2 times 1 is 2, 6/2 m minus 36/2 equals 18. So can we reduce? Can we reduce? I think we can, right? What's 6 divided by 2? Well, that's 3. And what's 36 divided by 2? Well, that's 18. Okay, here we are. We have arrived at a two-step equation. Add 18, add 18. We get 3m equals 36. Now I'm running out of space, but that's okay. I'm going to come back up here. 3m equals 36. I have to unstick the 3 from the m. I'm going to do it with division. And I get m equals 12. M equals 12. So if I go back in, I'm going to plug it into the modified version. 3m minus 18 equals 18. I know that 3 times 12 is 36, and 36 minus 18 does in fact equal 18. So 12 works. Hooray! Okay, last but not least, 11 equals 17 minus 5y plus 12. I've got two like terms here. These are both constants. So I can go ahead and combine them. 11 equals 17 plus 12 is going to be 29 minus 5y. Okay, don't be thrown off that the y is on the right-hand side. You can move it to the left if you want to, but if you move it to the left, that means you have to move everything that's on the right, or on the left already, over to the right, which just, there's more margin for error there. It's really not necessary. You have to change a bunch of signs. Let's just keep it how it is. We can handle it being on the right. It's okay. So I want to first get rid of the 29. I'm going to do so with subtraction because it's a positive 29. Okay. And that's going to give me negative 18 equals negative 5y. I unstick that negative 5 in the y by dividing and dividing. And this is just, once again, the fraction train is rolling. 18/5 equals y. I was dividing a negative by a negative. I can't reduce it, but it's going to wind up being positive, right? Because a negative divided by a negative is a positive. So I have y equals 18/5, and I want to check that. So I'm going to say 11 equals 29 minus 5 times 18/5. So these cancel each other out. And we've got 11 equals 29 minus 18. If I actually do the math and combine those terms, 29 plus negative 18, it gives me 11. So that is true. This is our solution, 18/5. Okay, I hope those examples were helpful. We're going to move on to variables on both sides. So same thing holds true. If you have more than one like term, CLT. If there are parentheses, you must distribute. Okay? And once you have two terms on one side and two terms on the other side, move the variable first. Okay? If you move the variable first, then you'll have a two-step. And we're getting real good at two steps, aren't we? The equation, not the dance. Tee-hee. Math pun. All right, so let's keep this going on the back. So once you have those two steps, there's a couple rules. You could solve it, and it could work out where you get a single solution equation. Wonderful. That's what we've been doing. That's what we're used to doing. When you move that variable over to the left, or to the same side as the other one, whichever you choose to do, left or right, if the variables cancel and the constants that are left are the same, your answer is infinite solutions, which is really cool. Infinite solutions. If your variables cancel each other out so that you have no variables left, and you'll see an example, and you have the same numbers left on both sides of the equal sign, that means that you could substitute any number into that equation and it would still balance out. You have an infinite number of solutions. Any number would work. If the variables cancel out and your constants are different, sorry for my bad grammar, different, I'm just going to put diff because I'm running out of space. What do you think that means? If the same values mean that you have infinite solutions, what could different constants mean? It means that your answer is no solution. I hate it when that happens. So unsatisfying. Okay, and of course, always check your answer. So let's try an example here. 5a plus 3 equals 12 minus 2a. I can't combine anything over here. I can't combine anything over here. I don't have any parentheses that I need to distribute to get rid of. So I'm going to move my variable first, and I'm going to start on the right because I'm in the habit of getting my variables on the left. I have a negative 2a, so I'll move it, quote unquote, by adding 2a, doing the opposite, and adding 2a. That means they cancel out on this side, and now I'm up 2 a's on this side for 7a total, plus 3 equals 12. Now I'm going to move the 3 because now I've got a two-step equation. I have 7a equals 9, and I'll divide by 7, divide by 7. A equals 9/7. Okay? For the purpose of keeping this video short, I'm going to break my own rule and not check these answers, but you will always check them on a test or a quiz or a homework or anytime you're ever doing any math. So do as I say, not as I do. I just don't want to keep you all in a super long video. Okay, let's try this one. M plus 12 equals 16 minus 4m. Let's move our variables over to the left by adding 4m to each side. That means these are going to cancel out. And now I'm left with 5m plus 12 equals 16, because I had 4m to my 1m. Okay. Now I'm going to do my two-step 5m equals 4. 16 minus 12 is 4. And then I'm going to divide by 5 and divide by 5. M equals 4/5. All right. So really you can see with both multi-step and variables on both sides, once you do that modification, either moving the variable so that they're both on the same side, or combining like terms, or distributing, you just have a two-step equation left. So you add and subtract, and then divide or multiply. Okay. Just as I was speaking about how we didn't have to do any of these extra steps, here we are. I've got to distribute here because I see parentheses. So I'm going to distribute my 2 onto the x and onto the 3. That's going to give me 2x plus 6 equals 2x plus 6. Okay, things are going to happen here. I'm going to move my 2x to the left so that all my variables are on the same side. I'm going to do that by subtracting because I've got a positive 2x, so I subtract and I subtract. That's going to cancel this out, and that's going to leave me over here also canceled out. 2 minus 2 is 0, 2 minus 2 is 0. My variables have canceled each other out on both sides, and I am left with the same constants. 6 equals 6. That means that we have infinite solutions for this problem. And we could put any number in here, and it would work, because the equation is already balanced before you even find what the value of the variable. Right? We can see that you're doing the exact same operation on both sides. So I could put in a 1, I could put in a 5, I could put in 1,000, and I would always get the same thing on both sides because we have the same expression on both sides. So any number will work. It's pretty cool. Now let's do this last example. We're going to distribute 2 to the 3x and 2 to the negative 6. 5x plus 10 is what we're given, equals 6x minus 12 minus x. Now I can combine my like terms on this side, and I've got 5x plus 10 equals 5x minus 12. Okay, I can see right off the bat, my variables will cancel each other out, but I don't have the same expression on both sides. So that means I have two constants that are not the same. 10 does not equal negative 12. In no world will 10 ever equal negative 12. So this does not work. No solution. No solution. All right. If you guys have any questions about this, just jot them down. You know how it works. We're going to do a lot of practice tomorrow in class of all types of equations, one-step, two-step, multi, and variables on both sides, so that you guys will be all set for the short quiz that we will have at the end of the class period. So please be sure you're writing down questions if you have them, and otherwise, we'll see you tomorrow. Great job.